Welcome back to my channel, everyone. Sri Tips here, and Mrs. Sri Tips has been at it again. And what we have here is some 14K scrap material. Put that in the melt dish. That's 137.3. I've got that recorded up here. Zero the scale. And I've got some 10K material. That equals 62.1. Got that recorded here. Now we'll zero the scale out. I've got some 18K material here. Add that into the dish. And that equals 25.5. I've got 24.5 over here, so I got an extra little bit of gold in there. That's okay. Zero the scale out. I've got a small pure gold button here from a previous refining. I'm going to add that in. We got 4.9. If you look at these numbers, I'm going to need 274 grams of sterling silver to quart this gold. I'm expecting 128.9 grams of pure gold from this lot. And what I have here is some sterling silver already pre-weighed out. Put this up on the scale. And we're talking 278.7 grams. I calculated I need 274.1. It's okay, this will work. So now what we're gonna do is take this material out on the melt table, and we're gonna quart this gold with this sterling silver. This is carat gold that we've accumulated over the last few weeks. And I just wanted to make a statement about this. The reason I refine this gold is to make these videos and to create a pure gold ingot. But I just want to say you do not have to refine the gold. I know there's a innate primal urge to melt this gold into an ingot. But if you do that and you ruin the markings on the carat gold, then its value and its purity become questionable. So it's best just to leave the carat gold just like it is. It can be held just like it is as long as you don't ruin the markings on it. It will track right on up with the bullion price. Here I'm adding the sterling silver into the molten gold, and the reason I'm doing that is to create an alloy that is a 6K gold alloy, or 25% pure gold and 75% silver and base metals. And it seems counterintuitive, especially to people that's never seen this done before, asking why in the world is he adding silver to the gold if he wants to purify it? And the answer is I must add this additional silver in order for the nitric acid to be able to penetrate in the next sequence of steps. In the past, people have asked me, why don't you just put the karat gold straight into aqua regia and dissolve it straight away in aqua regia? And the answer is for two reasons. Number one, you could get passivation. If there's a high silver content in the karat gold, then what will happen is the hydrochloric acid in the aqua regia will form a hard crust of silver chloride and prevent the acids from getting to the gold. Number one. Number two, if you put that stuff in aqua regia straight away, it creates a very dirty solution and makes the refining more difficult. Coating with silver and pulling with nitric eliminates both problems. Here's the encorded gold that we just alloyed. I add sterling silver to that karat gold so that now we can use these dilute nitric acid solutions and pull all the silver and all the base metals out of the gold and leave behind nothing but the pure gold. I'm going to set this up on the heat now. I don't have any heat going to it yet, but what we'll do is set this up on time lapse. I'll add these quantities of dilute nitric. Back here is a jar of sterling silver articles, and what I'll do is I'll dump off the nitric acid boils into this jar right here, and we'll consume any excess nitric that remains in these nitric acid boils. All right, it came out to check on this and got to start the camera for the time lapse. So the first nitric acid boil has been completed. Next dose of dilute nitric in here. And now we'll put it on time lapse and continue the process from here. Alloying additional sterling silver with this karat gold and then pulling it all back out with these nitric acid boils is one of the most valuable refining techniques that I've ever learned. It pulls all the silver and all the base metals that we've added, plus any silver and base metals that was already in the karat gold alloy. Those get pulled out as well. And when we get done, all we'll have left in the beaker is very high purity gold, ready for refining. You can see how the nitric acid in here is still just a little bit of a pale blue color. And that's indication that we are still pulling a little bit of copper out of here. For right now, what we're going to do is take this. See that? There's a little bit of color going on in there. We're going to add this to our flask down here and save this acid. Add some distilled water to this gold now. There's our gold. Look at that, man. That right there is high purity gold. Really close to 3/9 fine, just like it is. I'm going to boil this in a little bit of distilled water just for a few minutes. I had this soaking in hot distilled water for about an hour. And the reason I do this is the thought process is that this will leach out any additional silver or copper that might want to linger in these pieces of imported gold. And right now, the way this stuff is down in there, that's high purity gold in there. And we could probably melt that up into a bar and it would be very close to 3/9 fine, just like it is. That's how effective in coating with silver and parting with nitric acid is at removing the silver and base metals out of this gold. But we're not going to do that. I'm going to add a little bit more distilled water. Some nitric acid to this, and we're going to do one more nitric acid boil. And the reason I'm doing this is kind of overkill, but that's okay. It's best. The longer we spend under the nitric acid with this gold, the easier the refining will be later on. I've had this boiling in some nitric acid now for a little while. I'm going to kill the heat and let this cool down. This last nitric acid boil is complete. And if you look at the color of that nitric acid in there on the gold, you'll notice that it's colorless. That's what we're looking for. That means we've got all the silver and the copper pulled out of there now. And this nitric will have active nitric acid in it, so I'm pouring it off, and I'll save it, and we'll use it to do a future refining. I'm going to dump the rinses off into my silver jar. Here's our gold. If you look down in there, that's high purity gold right there. Very close to 3/9 fine, just like it is, without any further refining. Set our gold up on this heat source right here. This is about 4 troy ounces of gold. So I think what we'll do is we'll fill up our beaker here to about the 600 milliliter level with hydrochloric acid. You can see there's already some reaction starting to happen in there. That shimmering is from the 2 different acids, any residual nitric acid that's left on the gold, along with the hydrochloric acid that we just poured in. I'm going to add a shot of sulfuric acid, just in case we've got any lead in here. This will precipitate out the lead, form lead sulfate, and then we can filter it out. Got some nitric acid. What I'm going to do is measure out, let's see, we got 4 troy ounces. Let's go with about 60 milliliters, maybe just a touch under 60 milliliters. But what I'll do is I'm going to put this on time lapse now. We're going to add the nitric acid and dissolve our gold. Notice here that I'm using about 150 milliliters of hydrochloric acid and about 15 milliliters of nitric acid per troy ounce of pure gold. So I'm using a 10-to-1 ratio hydrochloric acid to nitric acid to form the aqua regia. I've got the solution evaporated down to drive off any excess nitric that may be present. Now we're going to turn the heat off and let this cool down. Adding ice will cool the solution down, precipitate out any silver chloride that may be present, and dilute the solution so we can get it ready to filter it. Here's what's in the funnel. Mix a little bit of the gold out of here if we can. And our solution down here looks nice and clear. Solution's nice and clear. Looks real good. Now we're going to transfer it into this beaker. Got some ice in here. The ice is made from tap water. Use some stump out, which is sodium metabisulfite, to precipitate out the pure gold. Here we go. All right, here goes the first spoon. Should take about 8 spoons of SMB. Looking at 4 tray ounces of gold here. There's 2. 3. 4. 8 spoons, that should do it. Let's give this a stir. See a little bit of color there, so we're going to add a couple more spoons of this. Make sure we got everything precipitated. This a stir. Just to make sure we've got everything mixed up real good in here. Alright, I went to test it with stannous, and I got no stannous. I forgot to make it earlier, so I'm going to add some pure tin shot, about 1.5 grams of this. Much. Now we're going to add some stannous chloride crystals, about an equal amount. Pour that to our bottle. We're going to add about 25 milliliters of distilled water up to about this mark right here. Okay, now we add about what is it, 30 drops of hydrochloric acid. Drop at a time here. Let's see if we can get that in there right. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 30. Now we just add the lid to this, shake it up, and it's ready to use immediately. I'm gonna write the date on here. What is today? 29 August. This is good for about 3 months. Now we're gonna test our testing solution. We've got a standard solution here. It's 1 gram per liter of platinum. We're gonna get a little bit of this on our piece of filter paper here. And now we're going to test the accuracy of our testing solution. And there you can see it's testing perfectly. That bright orange stain means we've got platinum in solution. All right, let's do another test. This time we're going to test with some of our gold standard testing solution. 1 gram per liter of gold standard test solution, and use our freshly prepared stannous and see what kind of result we get here. There you can see the stannous chloride testing solution is working properly. Got some palladium here. Go ahead and try to do this test as well, since we're testing our solutions. Gonna blot some of that off here. Some freshly prepared stannous on here. You can see we've got a positive test. Palladium in solution. Here's our 3 tests: platinum, gold, palladium. Let's get in here and test our solution that we just precipitated the gold out of with our freshly prepared stannous chloride testing solution. You can see by that negative test, all the gold has been precipitated. Allowed this to settle completely. What I'm going to do now is I'm going to empty the waste solution into this stock pot directly. I keep copper in here. Any traces of precious metals that are in these waste solutions will cement out on that copper. I'm going to go ahead and pour this right straight in to the stock pot, because I think there's a little trace of little traces of platinum group metals. We have white gold in this batch. White gold is a carrier of platinum group metals, so I'm going to pour this waste solution directly into my stock pot. Here's my temporary waste container, and what we're going to do is empty this out now into the stock pot. Got a significant amount of gold in here. We'll just hang on to this, let it accumulate, and then someday in the future we'll recover the gold out of here. Now what I'll do is use some boiling tap water and rinse all the chemicals off of this gold. I'm going to add some hydrochloric acid to the gold. And now what we'll do is cover this up and turn on some low heat and try to boil this a little bit in some hydrochloric acid. I've allowed that to boil for quite some time now in hydrochloric acid. I've got some boiling water here. I'm going to pour off the acid and then rinse it over and over with this boiling water. Here we go. We're going to transfer our gold now into a dish down here. Set this directly on the heat now and try to dry this off before we melt it into a bar. I was going to leave this directly on the heat, but then I got nervous, so I decided to put it on a water bath until we got most of the water evaporated off, and then I took the water bath away and put the gold on a plate with no water in it so that it could continue to dry completely. Let's take this over to the melt table now. Put this in a crucible and melt this up a pure gold bar. Here's our freshly minted pure gold bar. Look at that thing, man. Look at the shine on it. And just a single refining, it came out absolutely gorgeous. What are we looking for here? We were looking for 128.9 grams from this refining. And you'll notice I dropped some of it. That's a couple grams at least. I dropped some of it on the brick out there. I swept it into this container. I didn't want to add it with the gold because it's probably dirty. Might have some silver and stuff in with it. So we'll save this and refine it in our next video. And then let's see what we got for an actual weight on this thing. I can't help looking at it, man. It's just so beautiful. Let's see what we got here. 125.6. We were expecting 128.9. We probably got pretty close to it if I hadn't spilled that stuff all over the brick out there. Anyway, this will conclude the video. And I just gotta say it. There's nothing, and I mean nothing, like the look and feel of a pure gold bar in the palm of your hand. All right, this will conclude the video. Thank you for watching.